Alright, let's start looking at some auxiliary channels. These are channels that you can actually get from many different file formats. They're just options that you can check and kind of saves extra information for you. The one we're going to look at right now are all the ones that come with RPF files, and we're going to start off by taking a look at the normals pass. So first of all, we have our teapot. It just has a flat gray shader on it. That's it. I'll turn on two-sided just in case. And also I've put an OmniLight in the scene, but it's ambient only and set to 1. So it's basically just going to be a diffused full bright pass. Now what I'm doing is save the file. I've chosen RPF and I've given it the name normals. In the setup, we're saving a 32-bit floating point, storing the alpha, and I've checked on normal. We'll take a look at a few of these other ones in a little bit, but for now we'll start with just normals, and we'll render that. And I've already kind of set this up a little bit, but here we go. Now, if we look under here, some options have shown up because we rendered as an RPF, and here is the normals. Doesn't look like a whole lot here, but what you can do with it once you get into compositing is pretty cool. So we've saved that out. Let's go into Fusion, and I'll bring in that pass. Okay, here it is. Now the way to use this is we're going to go to Deep Pixel, and we're going to use a shader node. And we're going to connect this up, and we'll take a look at it. Alright, now first thing I'm going to do is I'm just going to take the specular all the way down. I'm going to take the ambient all the way down. And you'll notice we suddenly have a teapot that's got some light on it. What's really cool now is you see the equator angle and the polar height. If we start adjusting these values, we can actually relight this object from any angle we want, any direction, doesn't matter. And what's also interesting is that we do have the ability to turn on specular. Now, there's no way to map these or change what type of specular or what sort of shader we're working with. But it is kind of interesting that if you wanted to just kind of tweak your lighting a little bit, you could do that. You could add a little bit of specular, you can bring up the ambient light a little bit, and it's just really interesting that you can do this. Now, there are a few issues with it, a couple of big ones. For me, the biggest one is really that there's no shadows. I mean, if we light all the way from straight beneath, you'll see the top, or well, it's the underside of the handle, but it should be in shadow. And really, there's no shadows in this at all, no matter what. There are some plugins out there that will actually allow you to cast shadows from a normals pass, and that's some pretty cool stuff, but there's nothing that's built into Fusion that will allow you to do that. The other thing to notice about it is, let me get a decent angle here. You get kind of some weird anti-aliasing. Like here's the original pass, and you kind of get some weird stuff going on. So it's not perfect, and you can't really just go in there and light your entire shot this way. But it is pretty cool that you can make some slight adjustments to your lighting in the comp using this technique. And I mean, you can have as many of these as you want. So we could set up some rim lighting here. Maybe something like this, and you can just merge it right back on there, make it additive. There you go. Now you've kind of added some rim light. So yeah, there you go. I mean, it's It's not the greatest trick ever, but it is pretty cool. So if you have a use for it, try it out. Alright, in this example we're going to take a look at rendering and using ID passes. Just to introduce you to the scene, let's take a look at the materials and I'll show you what all we got going on. There's really just the box, a torus knot, and a teapot, and they have very simple materials on them. The box just has this gray nothing material. The torus knot has another very simple material, but it's got checker map inside the diffuse, and the teapot is also just nothing gray material. Another thing, we'll come back to that in a second. There's a little more to it than that, but if we take a look at the properties of these objects, one of the things you'll notice is the gbuffer object ID, which is set to 1. Now normally this defaults to 0, but I've already gone in and kind of set this up a little bit. So the box has an ID of 1, torus knot ID 2, and the teapot ID 3. Now in their materials they also have IDs. If we look at the material for the box, you'll see right here is material ID, and you can just come in here and just set whatever value you want it to be, and in this case I chose 1. Same thing goes for the teapot, only it's set to 3. And then we did something a little bit different inside inside the torus knot here. Inside here, like you'll see at the base level it's 0, so there's no ID there. However, inside these checkers, I've set it up so that all of the dark squares have an ID of 10, and all of the lighter squares have an ID of 11. And you'll see how that comes into play shortly. But let's just go ahead and we'll render this out and we'll start working with it. So turn on save. I've actually already done this once, but you know, I want to show you the settings that are being used, so hold on one sec. I have to go in and change it back. I'm using an RLA here, but you can also use an RPF or EXR, and the bit depth also doesn't matter, but I'm going to go with 16. And then you've got these extra channels over here, and the ones we're going to be looking at is the material ID, the object ID, and we're going to do the UV coordinates as well, and we'll also do the coverage pass. Alright, so let's go ahead and render that. Okay, here's our amazing masterpiece 3D scene. But inside the little drop down menu here, you'll see here's the passes that we had checked, and so we can take a look, and here's the material ID, and you can see everything that had a unique ID has a color representation for it. And then in the object ID, it's the same thing, except for this whole object had the same ID, not like the material where it was split up. And then we also have the UV coordinates, which is this kind of crazy looking pass, and it's really just using colors that will represent the UV coordinate space. And then finally the coverage. And the coverage, you'll see, has these sort of jagged outline edges, and that's going to actually help us in the comp, controlling some of these ID passes. So we went ahead and we rendered that out, so I'm going to jump over into Fusion next, and I'll show you what to do with these. Alright, so first thing we'll do is brought in the pass, and I'm just going to do a little bit of color correction on this. Alright, so I'm just going to pull it down into the blue, and you see everything is being affected. Now, and the way in which you use the ID passes is you go to this little radioactive tab here, and then you see we have use object and use material. So we're going to turn this on, and then what you can do is if you click and drag on this little pick button and mouse over the different objects, it's changing and using the ID pass as a mask. And you can see right here the numbers changing when I do that. So it's going to 3, back to 1, to 2, and it's applying that color correction only to the objects with that ID. The same is true for the material. If we mouse over this stuff, it will set the masking to use the ID. But another thing is, like with the material ID, we had set it up so that the checker material had its own IDs, and you can see if we just switch back and forth over the different areas of that texture, we're only affecting the area that's selected. So that's kind of cool. You can go in and make adjustments to parts of a material without affecting the whole thing. Now let's take a look down here. I'm going to switch it back to object. Not that it's going to matter, but see these kind of like weird edges that are sticking out, like the color correction kind of went over the edge of this object. Well, let's jump back into Max real quick, and we'll go to the object ID. You see what we got here? It's like this really jagged, non-anti-aliased edge, and that's normal. That's what it's supposed to do. Basically, these are pixels in which this object, even though it was being anti-aliased against the background object in the full render, part of this object showed up in that pixel, and so it needs to give it that ID so that it knows to apply color correction to that pixel. So that this is correct. You want it to do that. But then once you're in Fusion, you need to tell it to use that, and that's where that coverage channel comes in. It had the white and black with the black little outlines, and that's actually kind of a mask for this effect, so that it will smooth out these edges. And in Fusion, the way that you do that, and it doesn't always work, but let's try it. Yeah, it's not going to work for us. This correct edges checkbox here is supposed to use the coverage pass to fix that edge for you. I've had trouble in the past with different versions of Fusion, and it appears that I'm having trouble again with this one. But that is how it's supposed to work. This will fix the edges, but important thing to know is, let's say you're color correcting this one back here. Now the correct edges isn't going to fix this overlap here. Correct edges only works for whatever object is kind of in front. So if it was working and we had selected the torus knot, it would have corrected this edges normally. So it's important that if you're going to render these ID passes, that you also render the coverage pass, so that if you're lucky, it will fix this for you. Now there are some limitations you should know about if you're going to want to do passes like this, and the big one for me really is you cannot use image motion blur in these passes, in the material and object ID passes. So you would be forced to use either a 3D motion blur or a multi-pass camera motion blur technique, but image motion blur doesn't work. So I've found a different way that I like to create masks to use for color corrections, and that is by setting up an RGB mask pass, and I'll show you how to do that. Back into our scene here in Max, I've created 3 materials. I've got a red, green, and blue material. They're all 100% self-illuminated, and then they're also 100% red, 100% green, or 100% blue. And what you do with that is you assign these materials to objects in your scene that you want masks of, and then you can render this. And basically what you end up getting is In the red channel, you're getting only the box because there was no red in any of the other materials. Same goes for the green and blue. So you've basically got 3 different masks that you can use in Fusion. And what's great about this is it will work with image motion blur. If we had one of these objects kind of flying around and the edge was all smeared, you would still get a perfectly good mask that you can use out of that, because this edge here, let's say the torus knot was moving, you'd get this sort of green fall off into the red, but you could still just separate the green. It's its own mask. So this works really well with image motion blur. You're limited to only 3 different colors, but or 3 masks, but I often find that that's plenty. And if I'm needing more than that, I start to wonder if I shouldn't just fix it in Max. I shouldn't need to be doing tons of color corrections in Fusion. Should just set it up right in Max. But anyways, let's save this out. I'll just call this RGB mask. Interesting. Alright. Don't know why that just happened, but my computer crashed recently and I had to restart, so let's try RGB mask. We'll use TGA. Alright, I like that. So we'll go back into Fusion here, and I'll bring in that mask. And I'm going to set up another color correct node here. Alright, and again we'll pull it down into the blues. So there it is. Now the way in which you use this pass is you put a bitmap mask onto the color correct, plug this in, and then what you do is in the bitmap mask here, you've got this channel section, and you can tell it to use the red, the green, or the blue. And it's just as simple as that. You just pick which one you want it to be. And then what's cool is you get these really nice edges. You don't get that jagged edge that you were getting with the ID passes, and you don't have to worry about coverage. It's all taken care of. And there you go. I find this to be a more preferred way of doing it, but it also comes with the limitation of only 3 different masks per pass. Now we haven't so far taken a look at the UV coordinates that we had rendered out, so let's go ahead and do that now. Back to our original RLA file that we had created, and now we need to create a new node, and we're going to use the Deep Pixel texture node. We'll plug that into here, and one other thing we need to do is we need a texture to use. So I've got this brick texture, and what I'm going to do is I'm going to plug it into this input here, and you'll see down in the bottom left of the screen it says texture input there. So we'll put the texture we want to replace onto this object, and there you go. Now we've got the torus knot is getting the new texture mapped onto it. Now there's no shading or anything on there. This texture node is really intended just to replace the texture, like the diffuse colors. So if we had rendered out a bunch of different like lighting passes and shadows and all that stuff, then you could plug this in and get pretty nice results with shading and everything in there. But we didn't do that in this case. I'm just showing you basically how this works. But you'll see we lost the other objects in the scene, and you can just go into here and do it the same way as we were doing with the color corrects. Just go to Object ID, select that object, and there you go. Now it's not beautiful. It's going to take some work to actually make this look real nice, but it's kind of a cool feature, and maybe it's useful for you. Some objects in the background, or maybe you can actually get away with replacing some materials on a main character or something. But I've actually never used this in production, but you know, maybe it's useful for you, so I thought I'd show it. Alright, we're going to take just a quick look here at z-depth. In this scene, what we have is just a particle cloud, which is referencing an object, which is this torus knot, and so we've got a bunch of them just kind of floating around in space here. So we have that, and then we have the same sort of thing, only with teapots. So here they are rendered together. So let's go ahead and let's just render that. Okay, so here they are rendered together, and I'm going to save this out, and I'm going to call this just both. Alright, so they're both rendered together. Now let's turn that off and let's save this out as knots. That's a good name. And it's gonna, I wish this would automatically let you get at the setup controls, but it doesn't. So I want to, there we go. Okay, I'm going to save as an RLA. I'm going to go with floating point again, store the alpha, but this time we're going to use the z-depth and the coverage. Alright, so we've got our knots, let's render that. So there they are, they're rendered separate, and here's the z-depth pass. Now, z-depth pass is not anti-aliased, and that is correct, it shouldn't be. The coverage pass will help us to fix those jagged edges. So the coverage pass, basically the black and white values here, they control how much of what is behind is shown through on that edge. It's kind of like how transparent this edge is, or what do we see through that edge. Okay, so now let's turn on the teapots, and let's just call this pots. And we're using the same exact settings. Z-depth, coverage. Let's render that. Okay, here's the z-depth of that, and coverage. Okay, so we've got those passes. Let's head on over to Fusion, and let's just pull them all in. Now, what's cool about rendering with z-depth is that we can combine these back together again and have it render out pretty much exactly like this, where they're all matting each other out properly. And the way that we do that is we're going to just pipe these into a merge. And as you can see, we don't have it set up right yet. All of the knots are on top of the pots. So select the merge, and if we go to Channels tab, turn on this checkbox, Perform Depth Merge. And just like that, it merges them in at whatever their depth from the camera was. So now it should be pretty darn close, and it is. Now you'll notice that there are some slight differences, like watch right in here. Okay? And one thing that's really a problem is, like right here, this torus knot is going through the teapot. It was doing it here, and it's doing it here, but the coverage pass doesn't account for that. The coverage pass is only, let's see here, where's the Boolean? Let's put the coverage into the alpha and take a look at it. Okay, so here's that coverage. Okay, it didn't know that the teapot was in there, and the teapot didn't know that the torus knot was in there. So no matter what, this edge is always going to be kind of this ugly, chunky anti-aliasing. And the coverage channel helps to smooth out some of the other areas where things are on top of one another. But in this situation where they're actually penetrating each other, you're out of luck. So really, I don't like working with Z-depth. I just don't like giving these weird results. And the other things I don't really care about for it is that it doesn't work very well with opacity mapped objects. So like if you had a bunch of little plants mapped onto cards, then it's looking at the object itself. So if you had a plane with the opacity map on it, you're going to see the plane, not through it with the opacity. So that can cause you a little bit of a problem, but a lot of people like to use Z-depth to create fog or to do depth of field effects. So let's go ahead and take a look at how to do that. Okay, so let's create some fog. So I'm going to work with just the torus knots for now. So I'm going to go to Add Tool, and we're going to go to Deep Pixel. We're going to choose Fog. Now we'll connect these up. And just like that, we have some serious fog here. And if I play with the far slider, I'm able to control the density of the fog. And I can control where it begins too. You can also just select an object with the eyedropper, and that'll create the entire range of the fog. And so there you go, just like that. You can add fog, and here's the overall opacity. But you can also use the same trick to do depth of field too. So a way of doing that would be, we can just make our own little black and white depth pass. So I'm just going to turn the gain down on all of that, and then we'll make this color white. So here's our depth pass in black and white. And then what we can do is go to blur. We'll use a defocus. So connect that up, and we want to put a mask on it. We're going to set this to luminance. We'll connect it up, and then we have a defocus. So now this one was fairly close to us. If we take a look here, and this one was far away, and so it's getting blurred more. There's a bit of a problem with this though, and it's not really a problem with Z-depth, it's just a problem with doing depth of field in posts altogether. And that is that really this area, this white area, is being blurred a lot, and this area is not being blurred at all. And how do you deal with the in-between? Well, there's an anti-aliased edge here, which is kind of blending off. It's a value in between, and so you start getting these sort of like fuzzy edges, even around the ones that are supposed to be sharp. So I'm going to turn that up, and you can kind of see it here. It's sharp, but it's got this little kind of glow around it, and it's just because doing this sort of post blurring effect, you have these little edge problems. And back here, it's much better, because if we look here, these are pretty similar in value, so you don't really see the edge problem there so much. But in areas that are in high contrast, like here, it's pretty much black and white, you get this edge that's trying to be sharp, but it's kind of glowy and doesn't look quite right. So really, like, depth of field is really best handled in 3D, using depth of field in your camera. But if you want to use it as a post blur, and I do all the time, just be aware that you will sort of have this problem. So When I try and do depth of field in post, I'm usually trying to do it by separating a foreground, midground, and background and just blurring them individually. But you can also do it this way, and just watch out for that problem. Like, it's especially bad in situations where you've got a bunch of little grass blades or something in the foreground, and then it's a long, long way to anything behind it that needs to blur, and you get this sort of change in contrast. Always end up with problems, and I always end up having to separate my extreme foreground and background so that they can be blurred independently. Otherwise, you just get that weird glowy edge. But this is one way of doing the depth of field in post, and really, I mean, there's other ways to do it where you could translate the Z depth into a pass that you use and directly use, but I don't know, just piping it into the fog here works just as well. You're going to get results that are just as good. So there you go. Here's how you can composite with Z depth and produce fog and depth of field.